Okay, so today we're going to be working on pages 14, 15, and 16. There'll be a foldable on each page. We're going to be learning how numerical data and categorical data are different. And we're also going to learn how the outlier affects the shape, center, and spread. Remind me again what an outlier is. Right, the one that's very far away. It could be either one side or the other, okay? Way above it or way below it. But we're going to learn how an outlier will affect the shape, center, and spread. Okay, so remember, you're not gluing it down yet, but on page 14 is where we're going to start with this one about statistical questions. Now, you will be opening the first flap that says, what is a statistical question? And that's where you're going to write this. Now, okay, look up here at mine. What is a statistical question is the first flap. On the left is where I wrote down that how many letters are in my name and how many letters are in the names of all sixth graders in the school, and then non-statistical and statisticals. I wrote that on the left side. On the right side is where I wrote the definition. Okay? Okay, see how it's like two different things going on? Like you got a non-statistical question and a statistical question. That's what I wrote down on the opening part of my flap. Then over here on the part that will be glued down is where I actually wrote the definition of a statistical question. Okay, you can write on both sides. You don't have to try to fit it all right here. You can write on this side and this side. Does that make sense? So go ahead and write that. Which is measurable and written as a number. So like if you were doing a survey and surveying sixth grade students, their heights would be numerical data, because that answer is given as a number, normally in feet and inches or just inches. Amount of rainfall each month is measured in inches. It would be a number of inches. And the number of textbooks in a student's desk, that would just be like a whole number. Okay, now categorical data is data which can be divided into groups, like a flavor of ice cream, favorite flavor of ice cream. Well, how many scoops would be numerical, because that would be answered with a number. Eye color of students in the class, favorite beverage, that would all be categorical. Yes, that would be categorical. Numerical has to be given with a number answer. A frequency table is good, like if you're conducting the survey. Like say you already have your set answers, because normally when people conduct a survey, they try to give a set amount of answers. Like if you are surveying about ice cream, yeah, there's like a lot of different ice cream flavors, but it's best in a survey to try to narrow it down to like maybe the top 10, because otherwise you could have a lot of data, right? Because there's a lot of flavors of ice cream. So you would put whatever your selected answers are going to be, which in this case is just age ranges, and then as you go around and survey people, like this is like age range of 0 to 19 years old, then 20 to 39. So it looks like this person just went around like maybe the mall and said, how old are you? And if they said 17, they made a tally mark right there. If they said I'm 61, they would make a tally mark right here. And then once they were done surveying, they added them up, and that's the frequency. Yes, Krishad? Ages. No, I'm saying like if it was a totally different survey and you were surveying about favorite ice cream, you wouldn't want them to just be able to say any ice cream flavor in the world, because there are so many now. You'd probably want to pick the most popular and just say, out of these flavors, which is your most favorite? Right, like there were 2 people that were surveyed that fell between 0 and 19 years old. 8 people fell between 20 and 39. So the frequency is what you get when you total up all your tally marks. Okay, now, for a dot plot, obviously you wouldn't want to construct one of those until you had all your data completed. You wouldn't want to walk around the mall, you know, and saying, okay, year 1, I'm going to put a little circle right here. You would want to do that after all the data was completed so that you could show the frequency of it. Okay, now the next type of graph is a histogram. A histogram is used to show frequency distribution. Now, a histogram also looks like what other type of graph? A bar graph. But what's the main difference visually? Antoinette? Correct. Correct. A bar graph has spaces between each of them. The histogram is just all together. Okay, and it's used to show frequency distribution as well. Now, so if you're reading this histogram, it's saying like, if this is age, well, this says number of shares. I'm not really sure what they're talking about, what kind of shares. But it's saying between 0 and 20, there were 2 people that said they had between 0 and 20 shares. Okay, and then 5 people said that they had between 20 and 40 shares. Maybe on, yeah, well, shares like shares of stock or shares maybe on social media. I'm not sure exactly what they're talking about here. How many people said that they had between 60 and 80 shares? 6. Okay, between 60 and 80, it goes up to 6. So the frequency of that many shares was 6. Well, you just, okay, like over here, this bar would be between 160 and 180 shares, and 8 people said that they shared that much. Okay, now the last type of graph that we're going to talk about that we've already talked a lot about is a box and whisker plot. A box and whisker plot is used to analyze and compare large sets of data. A box and whisker plot is used to analyze and compare large data sets. Yeah, now you can glue this one down to page 15. Make sure you're gluing it down to page 15 now. This one will be glued down to page 15. Right. Okay, and then after you've glued it down, now we're going to start that last foldable, patterns in data. Okay, parts of a box and whisker plot. We already know this, so I'm not going to make you write it down, but let's just review it real quick before we move on. This dot over here is the lower extreme, also known as the minimum. It's the, it's the smallest number in the data set. The dot to the far right is the upper extreme, otherwise known as the maximum, which is the largest number in the data set. Now, when you connect those dots to the box, those are called the whiskers. The box is made of 3 vertical lines, and those are your quartiles. The first one is quartile 1, and it's the median of the lower half of the data set. The second one is quartile 2. It's also called the median, the middle of the middle number in all of the data. And then the third one is quartile 3, and it's the median of the upper half of the data set. Okay, so you don't have to write this down because we've already talked about that in detail, okay? All right, so now we are going to talk about measure of center, and it's at the top of the next foldable. Now, you do not have to draw the picture of the dot plot. You just need to write the definition. It is a lengthy definition, and it is a small flap, so make sure you're writing small enough to fit it all in there. Or if you can't write that small, you could write like half of it over here and half of it over here, okay? The measure of center at the middle, or is a measure at the middle or center of a set of data, and it is the balance point of the display. Generally, the mean or median of the set of data is used for the measure of center. Remember when we first started talking about statistics, we talked about measures of central tendency? Okay, that's the same thing. Measure of center, measures of central tendency. Now, the median will obviously always be in the center, right? It's always the middle of the data. The mean should be very close to the center, because when you're taking the mean, you're averaging it. You're trying to find the middle, right? What would cause the mean to not be in the center of the data? Right, an outlier. Say that on the first test, pretty much everybody in here makes either a 70-something, 80-something, or 90-something, but we have a few people that make like 30s and 40s. Isn't that, like, think, if you have like 70s, 80s, 90s, don't you think the average would probably be somewhere in the 80s? But if you have a few people making 30s and 40s, won't that probably bring the mean down into the 70s? So that's why your mean does not always end up being the best measure of center, because outliers can skew it. Okay, and we're going to talk about what I mean by skew in a second. That's what we're about to talk about. Okay, so now let's talk about spread first. So under the spread flap, you're just going to write that short definition. The spread of a distribution refers to the variability of the data. Well, it doesn't have anything to do with that. It's just if your data is all clumped together, like real close, that's less variability because it's less spread out. If your data is more spread out, then that's more variability. Now let's talk about shape, which is symmetry, peak, skewness, and uniformity. Wait, that's another. Okay. When it comes to shape of a distribution, it can be skewed right or skewed left, and we'll talk about exactly what I mean by that in a second. It can be symmetrical, it can be unimodal or bimodal, uniform. The shape of a distribution refers to how the data looks. It is described by symmetry, number of peaks, skewness, and uniformity. So try to write that definition like near the top, since this is such a big flap, because we might be writing more under it. Okay, so write this definition, but don't like spread it out a lot. Keep it near the top in case we need to write more. Slide. We talk about symmetry first. So you're also writing this up under that same flap. That's why it's such a big flap. A data set is symmetrical if it can be divided at the center and each half is a mirror image of the other. So like in a dot plot, you can see that if you divide it, if you draw a line right down the middle, it's symmetrical. 2 dots, 2 dots, 3 dots, 3 dots, 3 dots, 3 dots, 4, 4, and then in the middle is 5. Now it doesn't have to be that amount of dots. It just has to be a mirror image, the exact same on both sides. Same thing with this histogram. See how the different levels are the identical, like their mirror image on both sides? Yeah. Well, when divided at the center. Yeah, you'll need to put when divided at the center, it would have to be the same on both sides. Okay, y'all done with that one? Like Timmy? Well, then they just go by Tim. What? Do what? No. Okay, now let's talk about the next thing. Oh, that's the same thing. Okay, number of peaks. A graph can have peaks in the data where one or more data points have a higher frequency than others. And what is that called? What, like this is one peak because that's one mode, right? But over here, there's two peaks because there's two modes, bimodal. So you don't have to draw the picture, but you do need to write the definition of what peaks are. And then I would also write one peak would be unimodal and two peaks would be bimodal. Skewness refers to a data set where more observations are on one side of the graph than the other. Now, it's opposite of what people think, though, okay? You kind of got to go against common sense. Skewed left is actually when there's a tail to the left. See how it gets thinner over here? That's skewed left. Over here on this graph, see how there's kind of a tail to the right? That's skewed right. So when it's wherever it gets thinner is where it's skewed to. On the left side, there's less data, so that's skewed left. Over here, the right side has less data, so that is skewed right. You could just do something like this, like a straight line, and then write skewed left below it. And skewed left looks more like this. More of the data is on the right side than the left. And then over here, skewed right would look more like this. Like if everybody pretty much made the same score. If we had a test and pretty much everybody made in the 90s, the data would be a uniform distribution. Right. But then like if you had a few people that made in the 30s, and then a few more in the 40s, a few more in the 50s, 60s, a lot of people in the 70s, and then 80s, 90s. Well, I should have started lower to fill up those bars. But that would be symmetrical but not uniform.